Okay, guys, so today we're continuing proportional relationships. And yesterday we took a situation and we created a table and then a graph. Well, today we're going to go backwards. We're going to say, what if you're given a graph? How can you find the constant from a graph? So when you're analyzing graphs, first you're going to choose a point on the graph and tell what the point represents. So say I choose a point on a graph and it is at, let's see, x is 2 and y is 4. So I'm going to keep going with this cookie scenario I keep talking about. So if it was here, I would say you can buy 2 cookies for $4. So that's what the point represents. Okay, then you're going to determine the constant. So k equals y over x. And then you'll write an equation in the form of y equals kx. So like this situation, I take my point is at 2, right? X value first, 4. So I would go and take 4 over 2 is 2. Okay. So same thing we've been doing, we're just kind of doing it in a different order. All right. So here's our first graph. So the graph shows the relationship between time in minutes and number of miles that Damon runs. What is the constant? Write an equation for the relationship. So what we're going to do is I'm going to go ahead and make a table. Okay. So you can do it X or Y, up and down or across. I'm going to make it horizontal. So in this situation, X is time and Y is distance. Right? So we're talking about how many miles he runs in a certain amount of time. So my first point is at 10 minutes. So 10 goes in X. My Y is at 1 mile. Okay, and then 20 minutes is 2 miles. And then let's see, 25 is 2.5. And then 30 and 3. So to find the constant, I can choose any one that I want. So I don't like to work with decimals. Just going to go ahead and choose this one. So k equals y over x. Okay, so I'm going to take my y value, which here is 1, and put it over my x value, which is 10. So my constant is 1 over 10.
Mom, now can I do it?
And just 1 second.
No.
Okay, sorry about that. We just painted my daughter's nails and she wants to know if they're dry. Okay, so 1 over 10. So if you don't know what that is as a decimal, you can just do top in, bottom out. So 10. So 10 does not go into 1, so I put a decimal, and now I have 10. So 10 goes into 10 one time. So it's 0.1. So he can run 1/10 of a mile in 1 minute. Okay? So we need to write it as an equation. So when we write an equation, it is y equals kx. So y equals, you can either do it as a decimal or fraction, 1/10 x. All right? So what they're saying is so we want to write this in a complete sentence. So in your notebook, on the left-hand side, you can write it in a complete sentence. So as the time increases, we're going to use my constant. We did k equals y over x, so 1/10. So 1 1/10 of a mile, right, per minute. So increases by, or if we can do 10 minutes, 10 minutes, right? The distance increases by 1 mile, right? So let's look back at this. So as my time increased by 10 minutes, I went from 10 to 20, my distance increased by 2 minutes. Okay, so make sure that's written in the left side of your notebook. All right, so the second example says the graph shows the relationship between the distance a bicyclist travels and the time in hours. So our first situation, it says, what does the point 460 represent? So 460 is right here. All right, so it represents that a time of 4 hours.
Mama?
Yes, Avery.
Can I have a snack? What can I have for a snack?
You can go get a yogurt, Sweet Pea.
Okay.
So after 4 hours, and it says the bicyclist travels. Okay, so the bicyclist would have traveled let's see how far, 60 miles. Okay, so I'm just using the graph. I'm looking at my X represents 4, so it's 4 hours. And then my Y, 60, represents my distance in miles. So what is the constant of proportionality? So I can choose any of the points, and I'm going to do K equals Y over X. So if I choose the point they gave me, my Y is 60, right? Because it's always X comma Y. My X is 4. So if I divide that, 60 divided by 4. 1 times 4 is 4. 2, bring down my 0. 4 times 5 is 20. So my constant is 15. So that's telling me, right, if it's 15 and I think about my constant, it's per 1, right, per 1 mile. So 15 miles per hour. Sorry, so my constant is per whatever, right? Because it's 15 over 1. So on top is 60, that's miles. On the bottom is hours, so 15 miles per hour. So now we're going to write an equation, y equals kx. So all I do is substitute my k. So y equals 15x. So I take my number of hours and I multiply it times 15, and that would give me my y, my distance. Okay? So at this point, if you guys have questions, you need to be asking them, because this is the last day we're going to spend on constant of proportionality, and then we're going to move on to another concept tomorrow. So, and we have our test on Tuesday. So make sure you get all your questions answered. All right, so now we're moving on. This is the same type of concept. Yet again, I know you're going to be like, but it looks different. It does look different because we're using our formula of distance equals rate times time. This is just like y equals kx, okay? But y is always your distance, k is always your rate, and x is always your time. Okay? So I'm going to put it up here. It's very similar to y equals kx. So don't let it fool you. Okay. So here it says, if you traveled 3 hours at 60 miles per hour, how many miles would you go? So we're saying how many miles? That is distance, right? So we're saying distance equals rate times time. So we don't know our distance, but they're going for 3 hours at 60 miles per hour. So 60 miles per hour is my rate. So 60 times 3 hours. That's going to be my time. So 60 times 3 is 180. So they traveled for 3 hours at 60 miles per hour and they went 180 miles. Easy peasy, right? All right, if you need to travel 200 miles in 4 hours, how fast do you need to go? So again, distance equals rate times time. So now we have 200 miles. So that in this situation is my distance. So 200 miles equals rate times time. So how fast you need to go is your rate. And then 4 hours is my time. So rate times time. So times 4. So we're saying 4 times our rate equals 200. Well, I need to get my rate by itself. So right now this is multiplication. So I need to do the opposite operation. So I'm going to divide by 4 to get r by itself. And you have to do it to the same to both sides. So 200 divided by 4 is 50. So the rate is 50 miles per hour. All right, so go ahead and press pause, and I want y'all to try the last one yourself. Okay, so hopefully you text coded it and you realize that 200 miles is your distance at 400 miles per hour. So miles per hour is always going to be your rate on a moped. How long? So we want to know the time. So I'm going to fill in what I know. I know 200 miles. And my rate is 40 miles per hour, and I don't know my time. So yet again, I need to get my variable by itself. I want time by itself. So it's saying 40 times time, so we're going to do the opposite. We're going to divide by 40. Those cancel. Divide by 40. If I have 2 zeros above each other, those can cancel. So now it's just 20 divided by 4. So time is 5 hours. All right, so that is D equals RT. All right, so if D equals RT, what is the formula to solve for rate? So on the left side of your paper, I want you to show how to do it.
Now can I touch everything?
Yes, sweet pea. D equals RT. So how do you solve for rate? So how do you get R by itself? So just like we did a minute ago, we're going to divide by T, divide by T. So rate equals distance divided by time. So this is just like K equals Y over X type situation, and then Y equals KX. We're just changing what it looks like. It's the same information, we're just moving it around. All right, so now it is time to work on your independent practice. So you should be able to finish today both the sides from day 2. So that's where you're going to start. Once you finish that, you can go back and finish the rest of day 1, and then we'll work on Think Through Math. So make sure you ask questions today, guys, because your test is on Tuesday, and we're here to help.